This is then we'll talk about object animators, which is a way of animating that depends on the object's kind of values. Let's see how we can do that. I'm going to show them to Andrew. The studio starts. A new application is called this one object animator. And in my object animator, I'm going to go ahead and wait for everything to load up in here. And what they want to do is I want to head into all my layouts today. I have at least one object. So in here, very similar to the last time. I'm actually not going to experiment a lot. I'm going to basically go ahead and make a box. So that's going to be my box. This is going to be a view is going to have the background, and that background is going to be a red color. So I can see it clearly in here. And now I'm also going to add a button in here, something like a button over here. This button, I'm going to say, is horizontally centered and it is sticking to the top 20 on this button. The text, and it says animate. And it is actually saying animate button. And this one is as if for minority view. And that's all I want to be doing in here between my layout. So the rest of it has to be between my actual coat, my coat. I'm going to head into my uncreate. In my uncreate, I'm going to actually add a click listener for my brother, and then I say animate button sets on click listener. And in here we want to basically go ahead and make ourselves an object animator. And yet I'm going to show you first how we could make a single object animator. Then I'm going to show you how we could actually make more than one. Let's go ahead and say, in my object animator in here in my button brain is clicked. What I want to do is I want to say value. Let's say I want to move it on the translation of Y. So I'm going to say translation of Y, it becomes a object animator's object animator of float. So because we know the type of the animation we want to cause is float. If we knew if it is off type or without of RGB, so on and so forth. Now for the float, this thing, the very first thing you have to fit into me is the target. So the target is the red U, then we're going to have to feed into it the property name. So I'm going to say you got translation of Y, that is what I want to change. Then I'm going to go ahead and say, what is the current value of the property that you want to feed? I'm going to say red veil, not translation want, whatever is its current value. Then I'm going to go ahead and say make it right to you. That translation of Y plus, let's say 100. So what it does is basically says I want to move things on the Y, find the current Y, add another 100 to it and make it to that, just like the last time. We have to decide what the duration is. I'm going to say translation of Y, the duration, let's say this time 500 milliseconds. Another thing we could do is actually decide about this type of the interpreter, which is basically the way the animation runs. Whether you want your animation runs in a linear mode, which is basically a linear interpreter, which means it goes from the value of this one to this value in a linear mode. In every millisecond it adds a certain amount to it. You could make it like bounce interpreter, which basically makes it to go slowly at the beginning and faster at the end. There are several different types of interpreter. I suggest that you have a look through the documentation, so get yourself a little bit more familiar. I will show you a few of those myself soon as well. Now we got the basics of an object animator already, and this could very well work. Let's go ahead and see what we have in here. If we run our application and we head into our Android emulator, we should be able to tap on this button every time and move our object. Yes, it moves and moves in a linear way. And that's great. Now, I want to actually go in here and make a few changes, not because of any particular reason. I just want to show you how we would do it, even though I'm pretty sure you guys would already be able to manage it. I want to basically put all of this stuff into a function so I can call this function from time to time for whatever I want to be doing. Let's see how we're going to do that. I'm going to go in here and say, actually outside my uncreate, I want to have a new function. Let's call this one function. I'm going to call it animate, not dysfunctional. Animate is supposed to do all of these things except that. I want to be able to fit different objects to it, so I know which object actually gets animated. I want to fit different types of interpreter to it so I know which objects, what type of interpreter happens. I want to fit different durations to it and I want to type with different animation types. So let's see how we're going to do all of these. What I'm going to do is actually I'm going to copy this. I'm going to say let's copy that, paste it entirely in here. Now, the very first thing is I don't want this to always be on the view, so I'm going to cut that out. Instead of that, I'm going to say target is an argument in here of the type view. So you get that right on the target. So that's the first. And then the second thing I want to be doing is I want to actually say what kind of property I want to feed into. The property basically has two values. One of them is the type of the object and then the other one is the type of the property. So I'm going to go in here and say, let's call this one. Let's call it property, and then my property is going to be up the type property of types view end. Let's say float for now. We could make it even more extensive that it would accept other types. But let's keep it this way one step at a time. So instead of doing the animation on the view, the translation of why I actually want to write on the property. So whatever we feed in there, that animation we draw, then we have two other values. We have a value from and then we have a value of the two. So those are going to be very easy. I'm going to say from that's going to be a float and then I'm going to have a tool which is also going to be a float. So this becomes from and this obviously becomes to. So that's also taken care then. Or animation has a duration. So that makes sense to be customizable. So duration, which is also an integer, if I'm not wrong this time, or rather as long. So I'm going to say the duration becomes the value for here. And then we have perhaps the more complex one, which is the interpreter. So I'm going to say I have a value, let's call it interpolate, which is off the time after type time. Interpreter, and obviously that becomes my interpreter. So basically everything that was done within this animation statically, we are basically putting them into arguments of the function. So if we call that function is going to add that for us. Now, let's see what's the point of doing this. I'm going to go up here and instead of doing this whole block of code, I'm actually going to comment that I'm going to say instead of that, when I click on my button, do this, say animate. And the animated says when you have to feed all of these arguments. So the value of it is right. The view, then the property for it would be, I think we would translate y if I'm not wrong. So it would be a view. The translation, y. So I want to animate the translation y, if it then is going to say what's the value that you want to feed into it. I'm going to say, let's say you got the translation line and then the other value, which is the true value of it, is the same plus 100. We're just trying to mimic what we had in here. Exactly. So that has to have an f at the end of it. Then I'm going to go ahead and say that the operation is 500 and this is what is the interpreter. I'm going to say this time is decelerate interpreter. So I'm feeding all the values to the animator and is going to go ahead and animate the y-axis or animate on the y-axis. Now, if you run this application now, we should see exactly the same thing as we saw before, minus the fact that the interpreter is different. Last time was linear. The spine is decelerate. Let's see that. Yes. So that's working. Now, whether I could actually go ahead in here and I could apply the same set of formulas to get an animation on the output, for instance. So I could go ahead and say, let's copy this, paste it in here. So whenever we click, we get the animation on the y-axis, but we also want to get animated the alpha. And I'm going to say the object is the right view, but the value they want to animate is alpha. So the transparency, the value of it is going to be, let's say from 1. This is 1. Let's go to 1F first. Let's go to 0F, let's keep it at 500 milliseconds. So they go along with each other, and then I'm going to go ahead and say the linear interpreter would do better in here. So linear interpreter, so what's happening this time is if we run this application now, both of these animations will run almost parallel to each other. The top that in as it's going down, it also gets to be completely invisible. And that's the purpose of having this function here. Again, something that you might need. I've definitely had situations when I needed this. That's why I wanted to show it to you guys. There are other ways of running animation as parallel to each other. There's an animation set that you will see really soon, but this is also a good handy way of running different kinds of animations. And you can also change the durations between them. For instance, you could say that it gets to be transparent longer, let's say, in 2.5 seconds, than the object movement, so you can play around with this, try different ways for it. And this was like a very basic introduction to how big an object animator. Let's keep it up to here, and let's move on to our next lesson.